Welcome to day 10 of Advent of Code 2023. This was a really fun one. I enjoyed this. So, what we're going to be doing with this one is making a pipeline maze thing, and basically just following it around, and then some fun stuff in the second one. So, let's have a read. You use the hang glider to ride the hot air from Desert Island all the way up to Floating Metal Island. This island is surprisingly cold, and there definitely aren't any thermals to glide on, so you leave your hang glider behind. You wander around for a while, but you don't find any people or animals. However, you do occasionally find signposts labelled Hot Springs, pointing in a seemingly consistent direction. Maybe you can find someone at the hot springs and ask them where the desert machine parts are made. The landscape here is alien. Even the flowers and trees are made of metal, of course. As you stop to admire some of the metal grass, you notice something metallic scurrying away from you in your peripheral vision, and jump into a big pipe. It didn't look like any animal you've ever seen. If you want a better look, you'll have to get ahead of it. Scanning the area, you discover that the entire field you're standing on is densely packed with pipes. It was hard to tell at first because they're the same metallic silver colour as the ground. You make a quick sketch of all the surface pipes that you can see. The pipes are arranged in two-dimensional grid of tiles. So we have what I'm going to call pipe. Vertical pipe is north to south. A hyphen is a horizontal pipe, east to west. Then we have an L, a J, a 7, an F. These are all the different bends. We then have a dot as a ground, an S as the starting position. Starting position of the animal. There is a pipe on this tile, but your sketch doesn't show what shape the pipe has. Based on the acoustics of the animals scurrying, you're confident that the pipe contains the animal is one large continuous loop. For example, here is a square loop of pipe. Nice square loop of pipe there. If the animal had entered this loop in the northwest corner, the sketch would instead look like this. So we've got the starting position there. In the above diagram, the S is still 90-degree F bend. You can tell that because of how the adjacent pipes connect to it. Unfortunately, there are also many pipes that aren't connected to the loop. This sketch shows the same loop as above, just with extra stuff filled in. In the above diagram, you can still figure out which pipes form the main loop. There are ones connected to S pipes. The ones connected to S pipes, whose pipes connect to pipes. Those pipes connect to. And so on. Every pipe in the main loop connects to its two neighbours, including S, which will have exactly two pipes connecting to it, and which is assumed to connect back to those two pipes. Here is a sketch that contains a slightly more complex main loop. Here's how the example sketch with the extra non-main loop pipes is also shown. If you want to get ahead of the animal, you should find the tile in the loop that is the farthest away from the starting position, because the animal is in the pipe. Starting position. Full stop. Because the animal is in the pipe, it doesn't make sense to measure this by direct distance. Instead, you need to find the tile that would take the longest number of steps along the loop to reach from the starting point, regardless of which way round the loop the animal went. In the first example with this square loop, you can count the distance each tile in the loop is from the starting point, like so. These stories and the explanations get very long the further you get into Advent of Code. But yeah, anyway, so here's the examples with how far the distances are at each time. Here is that other example they had. Here are the distances for the tile in the loop. Now for this, I realised I've actually put in the second test example. So I'm just going to quickly copy. Let's go with. Yeah, let's go with this one. Okay, let's just get rid of all of this. In fact, there's a few different examples here. So we've got this one, we've got this one, and this one. It doesn't necessarily say how far that one is, so it only shows these two distance. So let's just do import PyTest, and let's do at pytest.mark.parameterize. That's going to do the text. And expected, and that is going to be an array. Okay, so there's the first one, and then we end that, and that is an 8, and then the other one we want, just so we have couple of different examples in here, is this one, and this one has 4 as the solution. So we have here the text and the expected, and then we're going to do assert solve using the text is equal to expected. Cool. So let's get started. So this one was interesting. There's a lot of stuff that I did for this one to work it all out. So let's just start by going over what we're kind of solving. There's a lot of boilerplate, I guess, I needed for this one. So, not necessarily boilerplate, but additional helper functions. So ultimately, this is a grid. So let's start with that. Let's make a grid, not a GURD, which is equal to string.splitlines. We're going to have a constant start position as S, or a start symbol is S. Let's say the start position is equal to none. Then let's just go over all of the rows and columns and find the start position. So for R and row in enumerate grid. Then we want for C and for C character in enumerate row. If the character is equal to start, then we have the start position, start pos is equal to this, and we're going to break. What I am going to do is just say that this is an optional tuple of int, and let's just import that. So from typing import optional and tuple. Cool, because otherwise we would get a lovely little error, compiler error, linting error, whatever we want to call it. Just there. So we have this start position, and then let's just say here set start pos is not none. Let's just give that a go. Yeah, so we get through it. We have found a position, so we know that that's working. This is just failing on the two different tests because we're not actually getting the right output. That's fine. Excellent. Okay, so from there, what we want to do is get the we essentially want to go over all of the rows and, well, we want to determine where we could go from where we are currently. So if we first, so we want to check each of the characters that we're from where we are, the start position. We want to look at all the different characters around it and see where we potentially could go. We can rule out some things straight away, but yeah. So if we firstly make a variable for the character, so the current character, we'll set that to none. Then we have we basically need to go over all of the different positions. So what I'm going to do is say prev pos is equal to the start pos, and then that way we can keep that reference to the start position all the way down. So while the current character is not equal to the start, we want to paths is equal to, we haven't made this yet, but let's see where we could go and get possible paths. Paths. Then we want to say the prev position is equal to the start position and start position is equal to paths 0. Current character is equal to grid start position 0 start position 1. So what we're going to do is we're going to get all of the paths. We're then going to say that the start position is equal to the first path of all of them. And essentially then set the current character to the position of the start, which will be now the first place that it could go. The reason we want to get the first place it could go is because there's only essentially 2 ways that it could go. So it says here that this is a loop. This is a whole loop of stuff. So if we start here, there's only 2 ways this could go. It could go here or it could go here. But when it gets to here, it can't go there. It can only go forwards, because otherwise we'll be going backwards. So if we then get to here, we can't go backwards. So we're only going to be going forwards. And so essentially we're just going to be getting the first entry each time, which is technically the only entry. But we're going to get all the possible paths because there could be multiple. Let's just generic pathfinding, I guess. But yeah, essentially that's what we're going to do. We're going to keep walking around, getting the current character, and we're going to increment the total by 1. And then finally, instead of returning the total, we're going to say total is actually we're going to return the int of the total divided by 2. Now, get possible paths. So this is where the fun starts. So with the get possible paths, we actually need to determine the current item or character and thing that we're on, the point that we're on. But we also then need to consider everything else around it to get the actual place we want to go. So I'm going to extract this to a function. Def get possible, because there's just a lot to this. Path. Okay, so what we're gonna need for the possible paths, we're gonna need the grid, which will be a list of strings. If we add list up here as well. Cool. So we have the grid, which is a list of strings, firstly. Then we have the current position that we're going to need, which is going to be a tuple of int and int. And we're going to have the previous position, which will also be a tuple of int and int, and we are going to return a list of, no, in fact, we're going to return a tuple of int and int. So this is going to be the only place we could go. Yeah. So, we're firstly going to be creating a list of paths, and we're going to return paths, return paths 0. In fact, I'm going to get possible path is that, and then we're going to do this path. Yeah. In fact, let's call this get next position. That's more like it. That's more like what we're doing. Get next position. And then this will become the next position. Next position. There we go. Nice. So let's just put in here assert len of paths equals 1. Because we want to make sure that we're only getting the one place that we could go from here, from the current position. So anyways, we have the whole grid, we have the position, the current position, we have the previous position. So what we need to do is then determine where we can go the current character, and using the current character where we could go, essentially. Really terrible explaining that, but yeah. So the current char is equal to the grid of the position 0, position 1. So that will give us the current character. So we want to go different directions here. So we can either go up and down, we can go left and right. So if we just look at all these different things, we have up and down, we have left and right, we have down and right, we have down and left, or right and up, however we want to call it. So it goes to the left and it also goes up, is this J. An L goes to the right but also goes up, or north and east. So this is all just the connections. So what we want to do from here is map these individual characters to directions. So this video is going to get quite long. I do apologize. So if we have okay, so we have the different directions we want to go. So we have up, down, which is going to be equal to, so we're going to have two sets of tuples. So we're going to have -1, 0, and 1, 0. So essentially we're going up one row or down one row. We're not changing the column. We then have right to left. I know there's northeast, southwest, but I just prefer up, down, left, right. Meh, is what it is. So we have this -1, and then we have this and 1. So that's left and right. In fact, let me do this. So now it actually makes sense. Up, down, right, left. Or let's... Oh, I can never make up my mind with stuff like this. So let's just call it left, right. Cool. So then we have right and down So this way we're going to go, or down and right, sorry. Down and right. So here we're going to go increment the row, and we're going to increment the column. And we're doing it separately. So yeah, we've got down and right. We then have down and left. So this will go down and will go left. We then have up and right. And this is essentially the same as the one above, except we're going negative, and 0, 1, and then we have up, left. So we have -1, 0, and then we have 0, -1. Cool, so we have these different directions that we're going to be checking. So given each character, we want to say where we could go, where we could check. So let's say possible directions is equal to dictionary. So we have an F. An F can either go right or it can go down. So let's say down right. There we go. So then we have a J. A J can go down and left. So let's pop those in. Cool. So then I'll just fill out the rest of these. So we have a horizontal, which can go left, right. We have a pipe, which can go up, down. We then have a 7, which can go down, and it can go left. Sorry, up and left. This one can go up. Let's just say this one is up and left. Up and down, down and left. And then we have right and up. Yes, we're going for these angles, these angle ones, we're saying from the angle point, where can we go? So for the F, we can either go down or we can go to the right from the angled point. For the 7, for the angled point, where can we go? Down or to the left. And then finally for an L, we can go up and we can go right. So that one is up and right. Cool. So now what we want to do is say, if we are on S, so we want to determine where we can move if we're on an S character, because there's our first port of call. Like, we're on an S, what can we do? So if current character is equal to an S, For direction in so what we want to do is try firstly up and down, left and right, but we want to try each of these different directions, so up, down, left, right, because that also covers the down, right, down, left, blah 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 blah. So we want to go up, down, and we want to also explode the left, right. For each direction, so we say new position is equal to, so we have the position that we're currently in, which is here. So the position of start plus the direction 0, and then we want position 1 plus direction 1. So if new position is equal to the prev position, we are then going to just continue because we have not yet found what we're looking for. We are also going to continue if the new position, if new position 0 is less than 0, or new position 0 is greater than or equal to the length of the grid, and then we want to do the same thing for the column, so new position 1 is less than 0, or new position 1 is greater than or equal to the length of grid 0. So if any of that is true, then we want to continue. We also want to continue if it is a dot, because we can't move on to a dot position. So if grid new position 0, new position 1 is equal to a dot, we also then want to continue. Okay, so let's say that we don't have an allowed position yet. So we'll say allowed is equal to false. So what we want to do is basically say if we are going in a direction and we are also so we're going in a particular direction and we are one of a set of characters, then we want to allow the movement, and we'll append the paths, append to the paths that we've got above. So if we firstly do if direction is equal to -1, so if we are going upwards and grid of new position 0 and new position 1 is in this set of characters. So if we're going upwards and we're either going to, and we're starting on a pipe and we are starting, if we're going upwards and the new position is in a pipe, so these are the upwards tiles that we could move to if we were going in the direction up, north. Then we'll say allowed is equal to true, or what we could do here is just say paths dot append new position continue, and now we just need the different variations of this. Yeah, we're done with that particular one. So if the direction is equal to if the direction 0 is equal to 1 and the grid new position, in fact let's just do new char is equal to grid of new position 0 new position 1, so then we just want to say in here new char, and new char in, and in this one we want to go, so we're going down this time, so we can either go onto another pipe, we can go onto an L, or we can go onto a J. So again we want paths dot append new position and continue, because we don't want to carry on. We could just do elif. Yeah, let's just do elif. New position. Let's do elif. Get rid of the continue, and then let's do elif direction 1 is equal to -1. So if we're going left and new char in, so if we're going to go left, we can either go onto a hyphen, we can go onto an L, because we can go in on the bottom part of it, or we can go onto an F as well. So we can go onto the top part of the F. Then we're going to go paths dot append new pos lf, and now we finally have here direction 1 is equal to 1 and new char in, and this time we're going to be going to the right, so we can either go onto a J, we can go onto a hyphen, or we can go onto a 7. And again, paths dot append new position. Set length of this return path 0. So we just want to make sure that the length of paths is 1. And if so, then we could technically just return that. But let's just see if this works. Wait, grid isn't defined because we've just called it G. There we go. Alright, so let's just see. Oh yeah, we didn't provide it any arguments. Let's get rid of the allowed as well, because we don't need that. Possible directions, we'll use that later. So to go into this, we need to provide it with the grid. We need to provide it with the current position, which is the the start position, and we then want to give it the previous one, so that's the prev pos. Undefined name G, so this is where we actually called it grid. There we go. Right. So we actually have two possible directions. Yes, we do have two possible directions because we are on an S, I believe. So let's just make sure that we print and let's just print the current character. So we want print current char equals, yeah, current char is S. So we're going to get that. So what we want here is so we're going to return the paths. We're just going to go down the first one because, yes, there's two different paths we could take. But essentially, we're going to loop back. So we'll just get the first one for now. So we'll return paths 0 because that's the first place we're going to get, and essentially we could just return the new position here on each of these. Return new position. And then let's just yank, paste, paste, paste. Oh wait, yeah. There we go. And it's later on we're going to do the assertion for this. So because we never get out of there, we should then do the assert the length of the paths is equal to 1. Need type annotation for paths. So this is going to be a list of a tuple of int and int. There you go. Are you happy? Okay, so we then move on to the next one. So then if we do print current char, let's wrap that. Cool, yeah, so then we're on a pipe. Great. So this is doing exactly what we want. So we get no other paths to start with. So now we've moved off of the first position from the start. We now want to move on to other positions. So given the new current position, we then want to try to move in other directions. So what we could do here is no, it's not. Cool. Okay, so let's now go over the directions that we could go given the current position. So we know that the next position was going to be a pipe. So yeah, we're not going to do them all necessarily individually, but in fact we are going to do them individually. I tell a complete lie. Yeah, just bear with me. So for direction in possible directions, given the current character, what we want to do here is say new position is equal to position. So we're gonna keep this same stuff here. Want to keep all of that. So let's just paste that in there. Get rid of that. Let's outdent all of this. Go down here. Outdent. Undo. Great. Cool. And so then we want to get the new character is equal to grid new position 0 new position 1. Cool. So given this, we know that there's only certain places we can go. There's only certain combinations of things we can move to. So if we are on a pipe, so let's say if the current character is equal to a pipe and the new character is equal to a pipe, then it's going to be allowed and we can return new position. If it is a pipe and we are going upwards, so we're going to a if we're going upwards, we can go to an F or we can go to a 7. If we're going downwards, we're increasing the row count, then we can go to a L or a J. So what we want to do now is say if the current character is equal to a pipe and the direction 0 is equal to 1, so we're going down a row, and the new character is equal to is in an L or a J, then we can return new position. And then it's just really a case of figuring out all the different combinations that we can use and putting them all together. So if we're going upwards, -1, and new character is in F or a 7, because that's the only other combinations we can go, then we can return the new position. So essentially, each character has these sort of these main two kind of combinations here. Well, for the pipe and the hyphen, we also have an extra one of it can go to itself as well. So if we just grab these, pop them down here, and if we change this to a hyphen, change this to a hyphen, and change this to a hyphen, then with these we can either go to another hyphen if the direction 1 is equal to 1, so we're increasing the column number, so we're going to the right, then we can go into a J, or we can go into a 7, and if we are going to the left, we can go into an F, or we can go into an L. So it's on those bottom and top that we're going in there. Cool, okay, so that's those. So then if we just grab these ones, we can then do the other characters. So we have, if we're on an F and the direction is direction 0 is 1, so an F we're going down, then we can go into either a pipe or we can go into an L, or we can go into a J. And if we are going to the right, because it's the only other way that we can go, so if that is equal to 1, and the new character is so this one we want a 7, a hyphen, or a J. Yeah, so the J is in here twice for the F, because we can either be going down into the J or we can go right into the J. So we can return the new position. Cool, so that's that one. So then if we add another set, this, instead of F, we're going to have a J. Let's undo that. Okay, so that is going to be a J, and we are going to either be going up, so this needs to be a 0. So if we are going up, so we want a -1, and this can either go into a pipe, an F, or a 7, because that's the ones you can enter vertically. And if we're on a J and we are going to the left, we can either go into an L, we can go into an F, or we can go into a hyphen. Yeah. Cool. Okay, so we have these. Grab those, go to there, paste. Okay, so we are then going to do a 7. I do apologize for this one taking so damn long. So a 7, we are going to be going down. So we can either go into a pipe, an L, or a J again. And we can either go to the left, which means that we can go into an L. We could go into a 7, or we can go into a hyphen. No, that is incorrect. We can go into a F. Yeah, I got confused because of this little bad boy. Cool, and then so if I grab that, go down there, paste that. So then we want, instead of a 7, so we have the F, the J. We've done a 7, so now we have an L. Let's put this one in here. And so for this one, if the direction is -1 and the new character is in pipe, 7, or F, then we can return it. And if we are going to the right, then we can do a pipe, we can do an F, no, sorry, a 7, or we could do a J. L goes into F's, L, 7, and J, yeah, cool. Then finally, if new char equals S, then we can also move to it. So we are going to then return new position. So then that gets us back to the beginning. So essentially, that should be the end of it. For each direction, we're going to try all of this. We're going to just then return the first one that we can, which gives us then the end. There we go. So we get these passing, which is great. So we have these two different tests, and we've got all the new positions. We didn't need the paths in the end because we just returned the very first one. And yeah, get to the end. Nice one. So part 2 of this one was even more fun. Part 2 involved finding how many points were within inside the path that you've just drawn. So I'm gonna call it there, and I'm gonna make part 2 a second video because this is already an hour for this one. So yeah, cool. See you in part 2 of day 10.